All right, so let's discuss limiting reactants and reagents. I will go back and forth. I guess limiting reactant is probably the better thing. What this does is, and we did this a bunch in class where we talked about how you run out of something. It'll involve starting materials, which are also known as reactants. There will always be two givens. So, for example, the simple way to look at this, if you have an Oreo that is comprised of having two Oreo wafers and then 3 grams of cream, and then you put all that together and you get one Oreo. And so, if we said you have, 40 wafers, and then you also have, let's just say 36 grams of cream. And the question is, how many Oreos can you make? Well, the Oreos you can make from 40 wafers, since each Oreo takes 2 wafers, that'll give you 20 Oreos, correct? And with 36 grams of cream, because one Oreo requires 3 grams of cream, that will give you 12 Oreos. So even though you have enough wafers for 20, the reality is you can only make 12 because you're limited by your cream, right? Your cream is limiting you. The wafers aren't limiting you. So we would say that the cream is the limiting reactant because it makes the least number of Oreos. All right. So when we go into a chemical reaction, it's not going to be much different than this. It's going to be basically, you're going to have something like propane and you're going to have something like oxygen. And let's say you have 10 moles of each, right? So here are our two givens. Our two givens are we have 10 moles of oxygen and we also have 10 moles of propane. So there's our two givens. And basically, we just got to figure out which product we want as long as we go to one. So this one actually asks for carbon dioxide specifically, but we could do the same problem going to water and just figure out which one makes the least amount. So because this is moles, and we discussed this already, that moles you can almost figure out. So 10 moles of oxygen, right, is twice as much as the 5 that the reaction needs. So for carbon dioxide, it'll give you twice as much carbon dioxide. So it'll give you about 6 moles of carbon dioxide. And if you're not sure how we did that, we basically just said from the balanced equation that for every 5 moles of oxygen, there must be 3 moles of CO2 produced. And that gets rid of moles oxygen. 10 times 3 is 30, divided by 5 is 6. So that gives us 6 moles of CO2. And now we'll compare that to what we can get from 10 moles of C3H8. So we will still have 3 moles of CO2 from the balanced equation, but now this time on the denominator, we're taking the 1 mole of C3H8, and then 10 times 3 is 30, so that'll make 30. So if the question is, which of these is limiting, it should be clear that this number is the lower of these two. So therefore, oxygen is our limiting reactant. Because this is the lower product yield or produced, right? It's the lower amount of product produced, so you're limited. Just like up here, we were limited by the cream because we didn't have enough cream to make more than 12 Oreos. Now we're limited by the oxygen because we don't have enough oxygen to make more than 6 carbon dioxides, even though we have enough propane to make 30 moles of carbon dioxide. We'll only make 6 because we'll run out of oxygen. All right, so this again features two givens, right? We had 10 moles and 10 moles. Percent yield is what you receive divided by what you expect times 100 if you don't understand with percentages. That's what percent yield is. And in the case of this little movie here, you will see that this guy is he is trying to get his stuck candy out, right? His candy's stuck in that machine, and what he wants to do is get it out. So currently, the reason he's so upset is because he has his percent yield is currently 0. So he was expecting he received nothing, and he was expecting one of the candies to fall out. So his percent yield right now is 0, and that's why he's so upset. However, as you can see here, as it goes on, I'm going to need to turn this down because he's yelling in my ear. All right. He's trying to get that candy there. And you will see after a few more kicks, trying to get that out, that there's this kind gentleman right here who just says, "What's going on?" And he looks, he's like, "Look, I think I got some money. Let me get this guy to calm down." He gives him some money. And then the guy is beside himself with joy because, look, he wipes a tear off his eye. He's so happy he's finally going to be able to get the candy he wants, which is right there again. He's making sure he has enough money. And then when he puts the money into the machine, he's now expecting, in theory, he's supposed to have two. He's expecting now two candies. So his expected went from 1 to 2. And as we see here, when the expected candy, no, he hits the button. It takes him a second time because he's so excited. But watch here. Here's the thing right here. And when he hits it, that one falls, but the next one gets stuck and he can't believe it. And the reason he's upset again is because his percent yield is still not where he wants it. He's now gotten 1 out of the 2 he expected, which is 50%, but that's not enough for him. So he's going to go back to work here and start kicking the machine some. And when he kicks the machine, you'll see right there that the 1 falls, and now he's got 2. So the whole point of that was that, I guess I can toggle that now. All right. He was trying to get his yield better. And by at first kicking the machine, it didn't help. He still had the 0. When the guy gave him some extra money, he was hoping to get 2 now, but only 1 fell out, which was 50%. And then by kicking it some more, he was able to get the full 100% yield. All right. This sort of shows you why you're kind of concerned with this. So platinum chloride, because it has platinum in it, it costs $1,000. If you have 5 grams of platinum chloride, that costs you $1,000. So 5.00 grams of platinum chloride. And that's a lot of money. And you want to get this platinum out of it. So you're trying to get out of it this platinum here. So we're going to convert platinum chloride. Oops. Switch back to blue. So we got to turn this platinum chloride grams into moles of platinum chloride. And that will come from the periodic table. So the periodic table will tell us that 1 platinum is 195, and then chlorine is 35.5 times 2. So that comes out to be 266 grams in 1 mole. That's a 266. So that comes from the periodic table. That gets us to moles, and now we can use moles of platinum chloride to get to moles of platinum. And here's where we're changing colors, and the changing colors happens from the balanced equation. So we're going to use the 1 that's understood in front of that platinum chloride and the 1 from that platinum. So we're going to switch like that. That gets us to moles. We got to go all the way to grams because our given here is 2.35 grams. That's what we got in lab. So we got to get this moles of platinum to grams. So we're going to go from 1 mole of platinum to, on the periodic table, you're going to see that's 195 grams. So this comes from the periodic table as well. And this one came from the balanced equation. So if you think about that highway, right, we started with grams of one substance. We converted that substance to moles using the periodic table. Then we went from moles of one substance to moles of another substance using the balanced equation. And then we had to use the periodic table again to get that moles into grams. And that's exactly what we've done here. Well, it's what we did here too, right? We got this from the periodic table. We got this from the balanced equation. And we got this from the periodic table. Same thing happened here. We got this from the periodic table. We got the next step from the balanced equation. And then the last step we got from the periodic table. So when you multiply 5 times 195 and divide by 266, you get 3.66 grams of platinum. So that's what you would expect, right? This is calculated. So our percent yield is the got over expected, right? So what we expected is what we calculated. So that's the 3.66 grams. What we got is right here in the equation is 2.35 in the question, rather. The question tells us 2.35 grams is what we recovered. And when you divide those two, don't ask me why that's happening, you get 0.64 or 64%. So 64% of what you started with is what you got, which means 64% of that $1,000 is what you recovered, which is not a great yield. And that's why this is important. You're trying to figure out what your yield is. And yield in this case is talking about the yield in a, it's talking about the yield as in like the money that you get as opposed to the yield of a car when you're going to let someone else get in front of you.